Good morning, good afternoon. I don't know if you can hear me. Probably you can hear me. Okay. Before we start, I'd like to thank you all for joining. Before we start, I have to say that this webinar will be recorded for wider publication in YouTube. That's all that I want you to know. So today we're gonna guide you through how the Sinterit LISA X can unlock the potential of selective laser sintering, or in common word, SLS. We'll be focused in three key areas: choosing the right materials, accelerated development through open parameters, and looking at some typical application where SLS delivers the most value. So, just to start with the printer, the LISA X is a Sinterit's compact industrial grade SLS printer. Compared to the earlier model, LISA Pro, it has a larger build volume and is much faster, make it suitable not only for prototyping, but also for small batch production. Its balance of precision, accessibility, and industrial performance makes it one of the most versatile machines in its category. So, SLS is all about material properties. LISA X supports a wide range. PA12 Smooth, for example, is the workhorse, durable, strong, and reliable for general use. PA11 Onyx is more flexible and impact resistant, and is also biocompatible, so it works well for medical and wearable parts. Then we have Flexa materials, are TPU-like powders, ideal for flexible parts like gaskets or wearables. And then we have polypropylene and composites for lightweight chemical-resistant parts. I have to say here, lightweight parts, also chemical resistance in some chemicals. This diversity allows us to match the material to the job instead of compromising. So now, when we're choosing a material, we consider four key aspects. First, mechanical properties. Do we need stiffness, flexibility, or impact resistance? Second, the application. Are we making prototypes, functional testing parts, or actual end-use components? Third, post-processing needs. Some materials dye beautifully or can be smoothed for aesthetics. And finally, cost and powder availability, which are important for scaling projects. For the decision framework, let's say that we can start from your application's requirements. What's the problem we have to solve and the part will solve? Which is the problem? Then narrow down the options based on mechanical and thermal properties. And finally, consider sustainability. LISA X supports powder with good refresh rates, which reduces waste and lowers costs. One of the LISA X, let's talk a little bit about the open parameters that the machine, this machine supports. One unique strength of this machine, it has an open parameter system. Unlike locked printers, it allows us to fine-tune variables like laser power, scan speed, and bed temperature. This gives us the freedom to adapt standard profiles or even experiment with new powders without being tied to preset recipes. The workflow, a typical workflow looks like this. We start with a baseline profile, which is inside the software of the Sinterit software. Then we adjust the parameters in small increments. For example, we change the laser power by 2%, or we increase or decrease the bed temperature 1 or 2 degrees. After each print, we document results, we compare them, and we refine further. This loop let us quickly optimize both quality and performance. The benefit of all this is that the speed, the approach is speed. We have the R&D teams can test more variables in less times. Failures turn into learnings faster, which shortens development cycles. And beyond that, it opens the door to using custom powders or blends that might not be officially supported yet, giving you an innovation advantage on this section. Of course, one of the most common uses of a printer and the SLS technology is the prototyping. With SLS, we can have functional prototypes that look and feel like final products. For example, snap fit parts, enclosures, hinges, and clips can be tested under real conditions before committing to mass production. More and more companies use the Lisa X for the end-use parts. Examples include spare parts for machinery, customized jigs and fixture in manufacturing, or lightweight components in automotive and aerospace. Because there's no need for tooling, SLS is perfect for low volume production and customization. Finally, specialized fields are embracing Lisa X. In healthcare, PA11 is used for orthotics and prosthetics because of its biocompatibility. In wearables, flexible TPU-like materials create comfortable and durable products. And in research, the open parameters make it possible to experiment with niche material for cutting-edge innovation. So, to summarize these little things I already discussed with you, or present to you, not discuss, choosing the right material ensures parts perform as intended. The open parameters we have, we accelerate and we learn and reduce the iteration time. And SLS, with the machine of Lisa X, is versatile enough to cover the entire spectrum, from prototypes to functional and use products. That's why it's such a powerful tool for innovation. This was a small presentation, let's say, referring to these three topics.